Or discount boards.
All right. Yeah, there were a few people that had like some summer months, but I suppose it could be water skis. It could be water skis, right?
Yeah, and plus if it was for winter, they could get them at a discount.
Discounts when they're on sale.
Discount price for summer.
Did you plug your
Who buys skis in January? You've got like less than a month to ski.
Yeah.
Like that.
Usually just one. So basically
All right. Okay, now forget that. Heck with that. We're not doing this. That's silly. Okay. Let's do those. Let's do those three right there. First one, Elise. Cosine. Now again, I'm going to have these identities on the quiz or up on the screen or whatever, or handout on that quiz day. Maybe you're starting to use them enough, you might have them about memorized, but that's fine. If you do, that's great. But cosine 90, cosine x minus sine 90 sine x is how the cosine one works, I believe. Okay, so if you got, make sure you get the right right signs in there. Cosine of 90, of course, is 0. Cosine of 90 is 1. And so you end up with 0 minus sine x, which is negative sine x. So it matches. So maybe an identity that uses something like that or something on the quiz. Remember when we verified it, we're not solving, right? We're not solving. We're put the vertical bar in there. We're showing the two sides are equal. Okay, 375. Now I did 330 plus 45. How many use 330 plus 45? Okay, what's another one you could use? 315 and 60. Okay, there'd be a whole bunch. You could minus if you wanted to, right? I don't know what that would be, but right, you could minus. So I did 330 and 45. Should get the same answer, right? Should get the same answer. So sine, that was sine, right? So that'd be sine 330 cosine 45 plus cosine 330 sine 45. You switch them around there. And so I drew it. 330's down here. It's 30-degree reference. So negative 1/2 be across root 3 over 2. So sine of 330 be negative 1/2. Cosine 45 is root 2 over 2. Cosine 330 be root 3 over 2. And sine 45 root 2 over 2. So it's negative root 2 plus root 6 all over 4. Just leave it. You notice that one shows up quite a bit. Okay? Whenever you're doing these 30s and 45s and so forth. Okay? Number 3. They're both in quadrant 1. X is in quadrant 1. Y is in quadrant 1. Okay, so both of them get drawn there. They're both cosine, so that's adjacent over hypotenuse. It's not one of our known angles, and so that's why I would just put a 2 and a 3. Now, I suppose you could put a 2/3 here like we do with the other one. You know, you could say cosine's the X. You could say that's 2/3. But then you could put a 1 there. Then that just gets messier, so I would not do it that way. I would do 2 over 3 to keep them whole numbers. I think is probably better in that case. You know, unlike this side where I did these, I think we can get rid of 2 over 2 of those. I like putting them on that way. But here, so Pythagorean theorem, so 9 minus 4 would be, this would be square root of 5. This side would be 49 minus 16. I think I did that right. You agree with that? Root 33 or those numbers you guys are coming up with. Okay, and I maybe didn't have time to get that all the way through it, but cosine x minus y would be cosine x cosine y plus sine x sine y. Okay, and so cosine x would be 2/3, cosine y 4/7. Of course, those are the ones you were given right there. Okay, And then sine x would be root 5 over 3. Don't worry about simplifying these on the quiz. I'm fine with whatever. Now these would simplify anyway, but square root of 5 over 3 is the sine. Opposite over hypotenuse. Sine y would be root 33 over 7. Then we multiply, that'd be 8 over 21. And then you just got to multiply. Now, I may, if we do a no calculator, my thought right now is just make the whole thing a no calculator thing. So right here, yeah, you might have to be able to do 33 times 5, and so you might have to do a little multiplying, right? 15, 16, okay, that's 165. So square root of 165, don't worry about simplifying it, over 21, okay? Just leave your answer like that. It's a no calculator thing, all right? And again, the common denominator should never be a problem, because it's typically, whenever you do one of these two are going to have the same denominator, so you're going to be able to just add them. Okay? All right, any questions on the homework problems? Any problems with any of those? Now remember, we didn't have a lot of questions on the homework the week before the last quiz, too. Maybe the homework wasn't indicative of the quiz. I don't know, the quiz was a little harder than possible. Okay? But was there anything? Yes.
How do you do 29 through 32?
29 through 32. So, give me an example of one of those. Just look at 29.
I'd like to figure out what it started with.
Oh, that's the, okay, good, because we're gonna do something like that. So, where's it at? Okay, so let's, well, look at any of them, okay? So 29 says sine 3 cosine 1.2. Okay, of the whole group of problems, these would be the ones you didn't need to do really any work, write anything down. Okay, so all you're doing is recognizing which one are you looking at. So you're looking at that and you're saying, which one of these am I looking at? Okay, so it goes sine then cosine. So that tells me I got to be looking at one of these two up here, right? Then I look and I see the minus, and that tells me I'm looking at this one right here. So that means my A and my B, my A and my B, that's my A and that's my B. So when I have a minus here, there's a minus there. So that means this one is sine of 3 minus 1.2, which is sine of 1.8, and that's all you do. You just write that. So too easy, right? I mean, you like there should be something more to do, right? Here's what I'll say on the directions on one like that. I'll say write this as a single function with one angle. Write this as a single function with one angle, meaning I don't want you to leave it 3 minus 1.2. I want you to write the 1.8. So when you go to one like 32, you look at 32 and you say, or let's just do 30. You look at 30, it says cosine, cosine. Okay, well that tells me cosine, cosine's got to be one of these. And then it's got a minus in it, so that means it's a plus in here. So that tells me that one 30's got to be cosine of something that's plus, so that'd be pi sevenths plus pi fifths, right? Now, on the quiz, I want you to put those together. So here's where you'd have to get a common denominator. So that's going to be 35. So that's going to be 5 pi 35ths plus 7 pi 35ths. So I would want your final answer to be cosine of 12 pi 35ths. Did we do 30? Did we do all of them in that section? We were supposed to, right? Okay, so for 30, I would want to see cosine of 12 pi 35ths. Okay? So it's just a does that make sense? And just a recognition. And since you have them in front of you, you know, that makes that easy. Okay? Okay, good. What else? All right. Go to your notes here. Let's do a couple of additional scenarios that we could run into. We don't have a lot of new stuff to do. Really, this is about it, to be honest, for the quiz. Like I said, I think I want to make sure it would be pushing it to do the quiz tomorrow. I just think we need some more practice time and time for you to have some questions here and so forth. So let's look at this scenario. Now this is something, there's two ways to do this one. We're gonna do it two ways. Okay? Now, the first way to do it, we could have, excuse me, we could have been doing ones like this for our last quiz. Now I decided to just stick with ones that had like a 2x in the middle or a 3x in the middle or something like that. Okay? But these were in our last section. Okay? But I wanted to wait till we did learn this new thing. All right, so if we were going to do it like we did one of these, what would we do right now? Forget these new formulas for a minute. You would think, where does cosine equal negative root 3 over 2, right? We would go ahead and get the cosine off of there, and we'd be left, so you can go ahead and write this down. I want you to work it both ways, because it's totally up to you. I don't care which way you work it. If this was on the quiz, I don't care. Okay? So we would do that, and then we would say, all right, where does cosine equal negative root 3 over 2? Well, that's in these two quadrants here. What's our reference angle if cosine is root 3 over 2? Isn't that pi 6? 30. Now we're doing this with pi, so this would be pi 6, and this would be pi 6. Okay, so what numbers are those? 5 pi 6 and 7 pi 6. Now, that's assuming we're going to go around 0 to 2 pi. Okay? Remember, when we did these before, we would do that, but then we might have to do some more, right? Because of that 2x or 3x. Now, it was a little easier when we had the 2x or 3x, because that just meant go around 2 times or 3 times, right? And we would get more answers. Well, we're going to have to do something a little different here. Remember, our x is between 0 and 2 pi, but we want x plus 3 pi halves. So what do we have to do to this? No, not subtract. You guys are always wanting to do that. You want to do the opposite. I don't have anything to subtract here. If I subtract, this would say x minus 3 pi halves. What do I want it to say? I'm going to subtract here, but not yet. I need to take this, and I need to say, okay, wait a minute. What angles work for x plus 3 pi halves, right? X has to be between 0 and 2 pi. So to be honest, it's very possible that these aren't even ones I need to do. As a matter of fact, it turns out they're not. What I need to do here is, what we did before is we came over here and we said, okay, if x is between 0 and 2 pi, then 2x would be between 0 and 4 pi. And that told us we'd have to go around again. Okay, well, I got to do the same thing here. So I've got to say, you can see why I left this off. This is going to be 2 pi plus 3 pi halves. Whoops, I forgot to add it to my 0. Plus 3 pi halves. Okay, so what do I have here? I have 3 pi halves. I have x plus 3 pi halves. And then over here I have, what's 2 pi plus 3 pi halves? 7 pi halves. Right? 7 pi halves. 4 pi halves plus 3 pi halves. 7 pi halves. Now, is 5 pi 6 or 7 pi 6, are those in between 3 pi halves and 7 pi halves? No. Matter of fact, let's do that in red. Where's 3 pi halves? 3 pi halves is all the way around to here, right? And then I need to look from there. And then where's 7 pi halves? Oh, 7 pi halves is around to there then, right? It's 2 pi, right? 7 pi halves is 3 pi halves plus 4 pi halves, which is 2 pi. So I need to look, so in other words, when I'm looking at my angles for x plus 3 pi halves, I need to look between 3 pi halves and 7 pi halves. So the first time around, until I get to 3 pi halves, I'm not even looking at those. So these actually have to, I don't even need those. I don't want them. Which ones do I want? I want the ones that, okay, I've come around to 3 pi halves. Now I'm looking 3 pi halves to 7 pi halves. So now I want this one and that one on my second time around. Well, what is this one the second time around? Not pi halves, it'd be pi 6. So one time around, remember, that's 12 pi 6, right? And then I've got my 5 pi 6. So 12 pi 6 one time around, and then 5 pi 6. So that's going to be 17 pi 6. And then what's this one? 19 pi 6. Okay, so I got to take my 12 pi 6 and add on the 5 pi 6 and the 7 pi 6. Those are the two that I want. Now I have to subtract 3 pi halves. Now remember, 3 pi halves is the same as what? That would be 9 pi 6. So now I need to subtract. Since I'm subtracting, we didn't care what we were dividing. But now that I'm subtracting, I got a common denominator. So subtract 9 pi 6. Well, what would that be? That'd be 8 pi 6 and 10 pi 6, which those actually reduce to 4 pi thirds and 5 pi thirds. Now those answers are between 0 and 2 pi, which is what I wanted. And that is kind of tricky. And you can see why I left that off last week. We had enough going on, I thought, last week. And to be honest, now that we've learned these identities, I think there's a better way to do this one. Okay? But I wanted you to see that. Now I think I've got it worked out here, yeah. So I've worked it out here and got that same answer. Okay, now let's look at what I think is a better way, which is to now expand this. Okay? There we go. So now, you guys do that. Expand that with our new rule that we have, with our new identity. Let's expand that. That's what we usually say with that. We don't want to say distribute, because that's not right. We're not distributing. Okay, but we're expanding that. So let's use our sum identity there to expand that thing right there. The left side. Now this scenario could be on the quiz, but there's not going to be more than one of them. Okay, we're going to do another one that's similar where another practice one, but our only option is to do this expanding thing. But I think it's the best thing to do anyway. I think when you have this, I think the best thing to do is expand. Okay, so what's the cosine one say? Cosine x, cosine 3 pi halves, minus sine x, sine 3 pi halves. Okay, and once you do that, okay, once you do that, now these are pretty nice. What's cosine 3 pi halves? 3 pi halves, that's down here. Cosine is 0, right? What's sine 3 pi halves? -1. So look what happens. That wipes that out completely. And this negative with this negative, look how much easier that is. Okay? Yeah, you don't have to mess with that other thing. When you got stuff on the inside, man, if you can rewrite it so that you don't have stuff on the inside, it makes it much better. So when this sine, -3/2, well, that's pi thirds referencing, right? So where is sine negative? Down here and here. Pi thirds reference. That's 4 pi thirds and 5 pi thirds. Well, look at that. Same answer. It's kind of cool, right? Totally different way of looking at it, but they're equivalent, so that's a way to do it. So and so the other reason I like saving it for now is that we can look at it and say, oh yeah, I can see where this could be useful for sure, solving this. We can do it the way we were doing before, but that makes it much easier. Okay? All right. Now, let's look at this problem. Okay? Go ahead and write this one down. Okay? Now, while you're writing, I'll just say that here's where we would not have an option to even do it the way we did the first way. Now, we weren't crazy about that first method anyway, but here, we don't even have that option because the goal of that first choice was to get the trig function by itself. Well, here you can't get these by itself. You can't add these two signs together. Because they're different. It'd be like doing sine x plus sine y. You know, if you're doing sine x plus sine x, that's 2 sine x. Okay? But if you're doing sine x plus sine y, you can't add those together. They're different. They're two different things. They're not like terms. Well, that's the same thing that's going on here. Okay? So go ahead and expand those out. Go ahead and expand both of those out. Once you get to here's what I would, and maybe you've already started going here. Like, what's cosine of 5/4? Root 2 over 2. Now, here's the only danger I would say. Now you could do it, but I think it might be smarter to just look at this left side and say, hey, I got 4 terms here. Can any of those combine or cancel? Well, I think they can, right? I mean, can't this one and that one just cancel out? Before you ever put a root 2 over 2 on there, I think that's probably the smart way to do it. And then what about these two? Just add them together and stick a 2 in front. Now, let's say you didn't do that. Let's say you put root 2 over 2 here, and you put root 2 over 2 here. Now, hopefully you notice that those cancel. Well, now you would have root 2 over 2 sine plus root 2 over 2 sine. Right? And then the dilemma would be, what do you do with that? Right? I mean, hopefully you would know that you could add those together. If you have 3 sine plus 4 sine, it's 7 sine, right? 3 plus 4. So this would be root 2 over 2 plus root 2 over 2. Well, that would be 2 times root 2 over 2, or it'd be just root 2, right? I mean, I'm not sure if that might cause you some confusion if you did that first. So that's why I think it's almost better when you have one like this, where it's got this long string of them, is to kind of combine them first. Now you could go ahead and put your root 2 over 2 in here. Well, if you have 2 times, well, what did I do? I'd say that was stupid, but I divided the 2 over, I guess, first. I divided the 2 over, and then I got my root 2 over 2, and then I divided that over. But now let's think about that. You'd have negative 1/2. You divide root 2 over 2, that'd be like timesing by the reciprocal. And that's going to be what? That's going to be negative 1 over root 2, because the 2's are going to cancel. And then you do root 2 over root, and so you're going to get negative root 2 over 2 anyway. Right? Negative 1/2 divided by root 2 over 2 is negative root 2 over 2. Okay? So, invert, multiply, however you want to do it. Probably been smarter to just take this 2 and cancel with that 2, and I'd have root 2 times sine x equals negative 1, then divide by root 2. Right? Then you'd have that, that's root 2 over 2. Okay, whatever. You get that. Well, where's sine negative, which is down here, which is a pi force reference, and then you got your 5 pi force and 7 pi force. Okay? So, not really too bad. I mean, you just do your rules for expanding. That's always going to happen, though, when you do that, is some things are going to cancel, and so we're not going to get into that too much. Maybe we'll review one more of those tomorrow, but there could be maybe one of those on the quiz, so maybe if there's 15 problems, there's one of those at the most. Okay? So, and there's a lot of partial credit opportunities there as well, so you can get it expanded, do that. All right, that's all I got for right now. So, we'll come back. Thank you. All right, think about some common mistakes on the quiz the other day. One of them was, and we can see this in a couple of different ways. For example, let's say we had a problem. I think we had something similar to this. Cosine to the 4th x minus sine to the 4th x. I think this was actually an identity problem.
Wait a minute. That is not fourth.
Okay, just checking. Sine to the 4th x. So we had this in a situation where it was, I think, an identity, and we had something else over on the other side. Okay, and so we were supposed to verify, and I don't even remember what it was, but I'll just make it real simple this time. It was something like this. We're supposed to verify. Okay, well, what comes to mind? And there could be several things that would come to mind in this side, but what turned out to be what we should have thought of on this one? What should we do on that side? It's a FOIL. It's a FOIL, right? And so it's a difference of squares. And so it's cosine squared plus sine squared. and it's cosine squared, and maybe it's because of the fourth power that threw us off. Okay, maybe that's what threw us off there. But that's a fourth power. Now, that doesn't mean you would always do that. For example, on this side, you could also think, well, this is going to be cosine plus sine and cosine minus sine, which it would be. But I'm not sure at the end of the day that it is helping, because what's cosine squared plus sine squared? That's just 1, so we get 1 times that, and now we're done. I know there was more to it than that. So now we're done. So in that case, we wouldn't want to factor this necessarily, but we would this. Now we could have. We could have factored this, and then once we got down to here, we could have factored that, and then both sides would have been equal. So that would have worked okay. All right, now, let's say we take it to a different scenario, and let's say we had a cosine squared minus sine squared equals, and let's say equals 0. Okay? So now, what would we want to do this time? It's a solve situation. Like, what do you mean? So change the cosine squared to 1 minus sine squared maybe, or change the sine squared to 1 minus cosine squared. Now, I don't think that would be awful. Now, matter of fact, let's do this a couple different ways and just show you, because that was what was happening when you had some options of what to do, and you would go down one road and kind of get stuck, and then you weren't sure where to go from there. And maybe if it was an identity and you did the other side, they weren't really looking alike. And so being able to recognize those things, I think, is important. So if I had a problem like this, cosine squared minus sine squared equals 0, I'm trying to solve, one thing I could do is what you said, I think, is a good thing. Now, maybe you'd want to add the sine squared over, but I think getting them in terms of one trig function is good. So maybe make this one 1 minus sine squared. Now, the only reason I would think to do that is because remember what I told you guys the other day, how we screwed this part up? You know, if you were putting in minus and then you put in a 1 minus cosine squared for that one, right? What happens now when you distribute that negative? What do you get? Minus 1 plus cosine squared. So you'd have to be careful of that if you did it that way, but that would work. That would have been fun. Okay, but if I just put a 1 minus sine squared in for this, I have to worry about it. Now this becomes 1 minus 2 sine squared equals 0. Then what would you do on this one? Subtract 1, I think. Divide by negative 2. And then what? Square root, and don't forget plus or minus. Now the square root of that is square root of 1 over square root of 2, which turns out to be, if you take top and bottom by root 2, this is actually root 2 over 2. Okay, so it's plus or minus root 2 over 2, which would be our pi 4s. It'd be in all the quadrants, 3 pi 4s, 5 pi 4s, and 7 pi 4s. Okay, when we're all done. But to get to that point, we would have to think about doing something like this. So here, maybe factoring would not be what you want to do. A lot of times we factor if we're going to cancel. That would be part of it. Okay, but you could have actually. Okay, we could have actually factored this. We could have said cosine plus sine. Let's just take a look at what that looks like. And cosine minus sine. Okay, so we actually could have done that. Okay, so what do we do at the next step? What do you do after you FOIL and you have 0 on the other side? You set each one of those equal to 0. So cosine plus sine equals 0. Cosine minus sine equals 0. Right? Now, what can you do with this? Now, you know, one of the problems here is we don't have it in terms of one trig function. So that is what a lot of times throws people off. So that's what I like about what we did. I like what we did here. Okay? But it wouldn't have to be that way. What can you do in this scenario? We maybe didn't do it quite like this. Let's move that sign over to there. Okay, now what can we do to get this in terms of one trig function? Divide by cosine. Now I know I just got done, telling you before lunch, don't divide. That, right? You lose some solutions. Now, that's in a scenario when I don't want you to divide is if you have a situation where you have cosine and 1 plus cosine equals 0, something like that. You divide by cosine to make that cosine go away. This cosine has to be a part of the solution. Cosine equals 0 or this equals 0. So that's a different thing. Here, if you divide by cosine, okay, yes, if cosine is 0, and where's cosine 0, which is up here and up here, you're going to lose those as possible solutions. But if you try those, they're not going to work. right? If you try pi halves, what's cosine of pi halves? Let's go back to the original function. What's cosine of pi halves? 0. What's sine of pi halves? 1. 1 squared is 1. 0 minus 1 is not 0. So these two solutions where the cosine is 0, sure, cosine will be 0, but sine won't be. Sine won't be 0. And so, those are not, you're not losing anything that is a solution in the original problem. In this one, if you lose the solutions like 90 or pi halves is a solution. If you have cosine plus cosine squared equals 0, right? And you lose pi halves and 3 pi halves as solutions, that's a problem. Because pi halves, cosine of pi halves is 0, cosine of pi halves is 0, 0 plus 0 squared is 0. You lose that solution. That's not a good thing. Okay? So losing pi halves and 3 pi halves up here will be a big deal. Losing pi halves and 3 pi halves here will not be a big deal. So anytime you divide, remember you can't divide by 0. So once you divide by a cosine or something like that, you're losing those places, those solutions where that is 0. Well, in this case, it doesn't matter. Okay, so maybe what you remember is when you turn a sine and cosine into a tangent by doing this, you're okay, right? Because sine and cosine are not 0 at the same places. Okay, so you're not going to have a problem here. So you get 1, and this is negative tangent. So you get tangent equals negative 1. Okay, this one over here, do the same thing. Get cosine equals sine, divide by cosine, you get 1 equals tangent. Now, where does tangent equal 1? Well, that'd be here and here. Pi force and 5 pi force, right? Where does tangent equal negative 1? Here and here. 3 pi force, 7 pi force. So there's your 4 answers, which are the 4 answers we have over here. So totally different look. Totally different look in how we solve that one. We get to the same answer. Now, I like, because I don't like the dividing thing, to be honest with you, I probably would have stopped when I got to here and just reasoned my way through it. When does cosine equal sine? When? In quadrants 1 and 3, when they're both positive or both negative, at pi force. And then at 5 pi force, right? When they're both root 2 over 2, or when they're both negative root 2 over 2. So that gives you your pi force and 5 pi force. And when is cosine equal to the opposite of sine, or vice versa? Well, that'd be 2 and 4. When one's positive root 2 over 2 and the other one's negative root 2 over 2. So you could have, when you get cosine equals negative sine or cosine equals sine, without dividing, you could just reason your way through it. Well, that only happens at pi force, or reference angles at pi force, when they're equal, or equal except for a sign change. Okay, so you could have stopped right there and gotten that answer too. All right, so that would have been a way to do it where you would have factored, but here would have been a way where we could have just made a substitution and went through there. Okay, so don't forget about those kind of things. Don't forget about this kind of situation. And then for God's sakes, the one that really drove me nuts the other day is when I give you something times something times something equals 0. Don't try to change those. Don't try to do a bunch of substitutions like identities. And I'm talking in a solve situation now, right? You just take this one equals 0, this one equals 0, and this one equals 0. You write those out. I'm trying to help you make it easier by giving it to you in, factored form. Okay, and that's the purpose of that. So don't screw that up, right? And make it tougher on yourself. All right, so those are just some things that came up the other day. We want to make sure we fix for the thing on Thursday. Okay, so let's go ahead and I'll let you work now on this. This is a worksheet from another book that previous teachers have used, but I'm kind of going to make you do more. Not really, but there's some of these problems have X's through them, and some. We're going to skip the bottom two, the mixed practice. But the rest of them we need to do. Okay, I think they crossed off number 8 on this one side because I saw it had tangent in it, and we're not doing that one tangent for you, but that's not what that is. That left side does not have anything to do with the sum difference. The right side does. Okay, so what I would suggest on 8, that one that's crossed out, that number 8 that's crossed out, I would expand the one on the right with our formulas that we have. And then on the left, just turn those into sines and cosines. Just turn those into sines and cosines and get common denominators. Okay? Now that's alpha, that's the Greek letter alpha and beta. Okay? So, when you have tangent alpha minus tangent beta, that's not zero. Those are two different things. Tangent alpha is different than tangent beta. But you can do sine. So you gotta be careful. You can't just write sine over cosine. You gotta write sine alpha over cosine alpha. You gotta write sine beta over cosine beta. And then you gotta get a common denominator. Okay? And it'll work out just fine. We do that. So skip 11 and 12 on both sides and do the rest. Okay, you guys can work together if you want. Work alone if you want. The key in both of those scenarios, okay, is work. Not to pick on anybody.